In Module 6, you'll be working with Expert Skills Session 4, which covers naming and formula auditing. These are great tools for the serious Excel user. Not only does naming, as we've already learned from prior projects, help us make our formulas and functions easier to understand, it can save us time. I'll let Mike Smart cover this because he does a great job with the topic. Feel free to reach out if you have any questions. The other part of this module is working with forms. Later in the semester, we'll work with the very old technology of forms built into Excel, but both Google and Microsoft offer forms as a separate online tool to use for surveys or quizzes. They can also be used for easy, repetitive data entry. While we're not going to make repetitive data entry forms in this class, we will be working with this data later in the course, so it's worth sharing a collection story now. My husband and I bought some property many years ago, and we are doing all our own work with clearing the land, milling the lumber, and building stuff. Bedrock sits very close to the surface on a lot of the property, and especially where we've chosen to build. In Vermont, we need a 4-foot deep frost wall of concrete to keep floors from cracking and heaving like our roads do in the springtime. But we hit bedrock usually at less than 4 feet for our frost walls. We dig until we hit bedrock and then build the frost walls from that level. In the past, we jackhammered the bedrock down to 4 feet and hit water, which flooded the excavation, and we had to give up on it. In case anyone wondered why we chose to build on bedrock, barring an earthquake that hits our property, it really is the strongest possible foundation. We're using insulated concrete forms, or ICF, to build our walls, and the brand we use, Quadlock, allows us to build from flat horizontal surfaces that vary in height. First, we have to build a footing, which is a wide pour of concrete that supports the walls. Then we build our styrofoam forms on top. With Quadlock, our forms can step, and it doesn't have to be full 1-foot steps. This doesn't really have anything to do with the form process, but it can help you what's going on here in this project. This is going to be a 36-foot by 24-foot structure with a wall across it 12 feet from the south, making a 12-foot by 24-foot room and a 24-foot by 24-foot room. The 12 by 24 room is our future sugar house, and the 24 by 24 room is a double car garage. We got the base area graded down to with 1-foot level across the whole area, knowing that we plan to put 2 feet of concrete above grades, so the entrance side will be level with the outside ground, and the back side of the structure will only have about 1 foot of exposed wall. Then we dug out the footings with our backhoe until we hit bedrock. The last bit of digging down to rock is done by hand with a shovel. We formed up the footings with 2x4s because plywood is expensive, and I had a lot of 1x6 boards I cut on my sawmill. We used the 1x6 boards and a little scrap of plywood to build the framing of the footings to contain concrete. Once we had the footings all framed up, we needed to calculate how much concrete to have delivered. Most of you have probably not poured concrete before, but when you order concrete, you take all the concrete they bring. If you order too much, you need to find a place to dump it. If you order too little, your pour won't get filled completely, and that's a bad thing. We'll use a spreadsheet to calculate the volume of the concrete later, but we're going to use a form to get the data now. The volume of something is its width times length times height. Our surface area, or width and length, is easy to calculate, but our depth, or height, is variable throughout the whole structure. To measure the variability, I made a story stick. That's what you see in this picture here. Our footings are all 19 inches wide, so I made a stick with feet on either side on the bottom that would slide on top of the forms. My husband then measured along each section of footing and gave me a distance from the end of the wall. Then, at 0 inches, he'd measure the depth, and any place along this stick, he'd measure at the inch marking where it was variable, and again at the 19-inch part of this stick. I sat on a milk crate on the outside of the hole and entered the data in Google Form on my phone as the measurements were called out. Here's what the form looked like. Now, this is in the entry mode. My first question that I asked was, which wall are we working on? There are 5. The east and the west are our 36-foot long walls. The north, south, and center walls are the 24-foot walls. We needed to measure from how far we were from the beginning of the wall, or from 0 to 24 times 12 or 36 times 12. There were points in the wall where the height changed of the footings. For example, if we were measuring at this point here, there's a box that has a height at this height, or this lower height here, and then this next box has this height, which is a little higher, but we need the depth measurement at this level and at this level at the same point. We'll see how that is important when we do the volume calculations later, but for now, that's why that checkbox is there. Then I had a pull down menu that offered distance across, and I could pull down here, and my choices were 0 through 19. Having these numbers in here helped me eliminate error by adding an extra digit, by having just a text box to enter a value, and it was actually really fast to pull down and then choose a point on this pull down menu. Then we would enter a number at how deep it was at that point on the story stick, and if I wanted to have any notes about this measurement, I could do that. Once I hit submit, I could start a new form over again and enter all the same data. Here is the form in editing mode. We can see that I entered 767 responses, and these charts aren't very helpful. What is helpful is looking at it in the spreadsheet that it entered. Now, column A is actually a timestamp because Forms automatically enters a timestamp for any entry in a form. But then here are my values for the different measurements that we called out. So on the south wall, at the farthest west point, we were at 0 inches from the wall. We measured at both 0 inches on the story stick, 10 inches, and 19 inches. And this helped us calculate the area of that. And then I will instruct you later how we calculated volume from these different measurements. Then at 7 inches from the end, the different points we measured at and how deep they were. And so it took us a few hours to do this, but using this data and then using spreadsheet functions, I was able to calculate volume and had very little concrete left over after doing all the calculations. So it was a huge success. In fact, here is a picture of all the concrete that was left over after the pour, which was very little considering we filled all that concrete in throughout the whole footing. Next up in part 2, I'm going to go over how to do surveys.